Algebra 2. Today's notes is on section 4.2, standard form of a quadratic function. The last section that we covered was learning how to graph parabolas using vertex form, and we had to learn the 5 criteria. So this section is a little bit different because it gives the problems in standard form, which is y, or f of x, equals ax to the second plus bx plus c. Recall from the past that this term that has a power of 2 is called the quadratic term. So this one is quadratic. The bx term is the linear term, and the c term is called the constant. So ax squared is quadratic. The bx is linear because it's x to the first power. And then the last one's the number by itself, and that's called a constant. So all the problems that we work in this section will look similar to this form. We're still going to have to know how to find the 5 criteria for graphing, and just reviewing from previously, you have to give me the A. Remember, A determines the steepness and the direction of the parabola. You're going to then give me the axis of symmetry. Before we abbreviated it AOS. Remember, that is the imaginary line that goes through the middle of the parabola. And when you give me an answer for it, you have to record it as an equation, x equals some number. Another piece of information that you're going to need to find before you graph is the vertex. We need to know where the starting point is. Vertex is either the high point or the low point on the parabola, depending on which way it is turned. Another piece of information that you've got to give me is the y-intercept. Again, this is all criteria that we've learned in the past. We're going to continue to find these 5 pieces today as well. And then the last thing I want you to list before you graph is called the symmetric point. So in the directions for your assignments in this section, when you hear me say criteria, graphing criteria, this is what I'm referring to. The 5 pieces of information that have to be listed for each problem before you graph. You have to give me the A, the axis of symmetry, which is an equation x equals some number, the vertex, which is the starting point of the parabola, a y-intercept, which is a place where the graph crosses the y-axis, and the symmetric point. And so in a few minutes, I'll model to you a couple examples. We'll go through all the pieces so you know exactly what to do. Again, this section is 4.2, and we are learning how to graph quadratics, which are parabolas, when the problems are in standard form. The AOS, the axis of symmetry, can be found by using this equation. If it's in standard form, this must be used. And so in order to find this answer, x equals some number, you're going to have to take the A, the B, and the C, the numbers in your problem, especially just the A and the B, and put it in this form to figure out the answer. So when I ask you for AOS, you're going to find it by doing x equals the opposite of your B. So whatever this is in front of your x, you're going to do the opposite. You're going to divide whatever that number is by 2 times the A value, which is the coefficient of the quadratic term. Once you simplify that fraction, then you're going to know the AOS, again, which is the middle of the parabola. So, for example, let me show you before we move forward. If you have the equation y equals 3x squared minus 6x plus 8. Based on the way I've written this out, it's definitely standard form. I see the quadratic term here. Linear term is the negative 6x, and the constant is the 8. To find the AOS, the middle of this parabola, I'm going to need to use the form x equals negative b. Now the b in this problem is the negative 6 right here. And so when I write it on top, I'm going to do the opposite of negative 6. And divide that by 2 times a. And the a in this problem is 3. So you'll just follow this form. This is an equation. And this formula will have to be memorized. You have to know that in order to do this. But it's always the negative version of b. So if my b is negative 6, I'm going to do negative 6 on top of the fraction divided by 2 times the a, which is 3. To simplify this, of course, you're going to do, let's do numerator first. The opposite of negative 6 is positive 6. On the bottom, 2 times 3 is also 6. And we're done with division. So 6 divided by itself is just a nice whole number, 1. And so with this quick example that I created, the middle of the parabola would be at x equals 1. Recall from the past, that basically means this. Here's my x-axis, here's my y-axis. That means I'll find 1 on the x-axis, and I will put a dashed line, kind of draw it in that way. Let me try that again. And that is going to be the center of my parabola. A little cricket there. Based on this equation that I created, the a is always going to be the coefficient of x squared, so my a would be 3. Because it's positive, that means the parabola is going to open upward. I still don't know my vertex yet with this problem, but I'm going to show you in the next slide how to find all of it. So for the first slide, I just wanted you to know that because these problems are in standard form and they're going to look differently, the way you find AOS is this way. You'll have to use that formula. You'll have to figure out what that is, and that's a really good starting point. Find the middle. Okay, so that is our learning target, is basically learning how to graph parabolas when the equations are in standard form. And so we're going to do that right now, graphing quadratic functions in standard form with example 1. Y equals x to the second plus 2x plus 3. We're going to list air graphing criteria. And that's going to be the A, the vertex, the AOS, the y-intercept, and the symmetric point. Those are the pieces that I need to find. Okay, looking at my example 1, I see y equals 1x the second plus 2x plus 3. Again, this is called quadratic term. This is linear, and this is constant. The a, based on my form, is always the coefficient of my x squared term. And so in this case, it's going to be the understood 1. So I'll put a 1 there. And what I would like you to do, as you've done in the past, is to always describe that. So like here, beside the a is 1, you will say opens up. And you're going to say same steepness as the parent. It's positive, so it opens up, and it's just a 1, and so it has the same coefficient of the parent graph, so that's why it's the same steepness. Okay, the next thing we're going to do is we're going to skip to the AOS section. On the AOS, you're going to find it using the x equals negative b divided by 2a. Making sure we remember the formula from the last slide. You're going to take your problem, and I'm going to work this to the side since I don't have a lot of room. So it's x equals negative. My b in this problem is positive 2, so I'll just write down 2, over divided by 2 times a, which is 2 times the 1 in this problem. And so my AOS is going to be x equals negative 2 divided by 2. And so that's going to be x equals negative 1. So that is my axis of symmetry. That is this piece. Alright, so all that work I did to the side, I didn't leave myself a whole lot of room here, but all of that work goes with this. Now what that's telling me very quickly is I'm going to go ahead to go over here to my graph paper before I continue. I'm going to go ahead and fill in the x equals negative 1. Here's my x-axis, here's my y-axis. X equals negative 1 is here, so I'm going to go ahead and draw in a dashed line. Alright, so at least I know where the middle of this parabola is. Next, I really need to find the vertex. Well, because this is not in vertex form, it's not as easy and quick to answer. So what I'm going to have to do is recall from the past that the vertex is definitely somewhere on this axis of symmetry. And so since I already know the x value, and I'm looking for an ordered pair, I know that the x value is negative 1. I just got to figure out what the y value is. And so what you'll do next is you'll take your equation, and you'll substitute where you see the x up here, you're going to put negative 1 in its place. Again, I didn't leave myself a lot of room, so I'm going to just show it to the side. When you're working it out, just work down the page. You'll have more room. Okay, so then you're going to work this problem out. You can use your calculator, just PEMDAS. Negative 1 squared is 1. We do powers first, of course, so that's 1. Multiplication next. 1 times 1 is 1. 2 times negative 1 is negative 2. So we got 1, a negative 2, and a positive 3. 1 minus 2 plus 3 is going to give me a 2 back. And so my vertex is going to be negative 1, 2. So I'm going to, as soon as I find it, I'm going to come over here to negative 1, 2, and I'm going to go ahead and put my point. Alright, reviewing y-intercept. Y-intercept is the place where this graph is going to cross the y-axis. So it's going to be 0, comma something, some number. In order for me to figure out what that is, I'm going to take the equation, I'll kind of leave that blank right now. We're going to go back to the equation, and we're going to put 0 in place of x. So this is the work you'll show for the y-intercept. Y equals 1, parentheses, 0 squared plus 2 times 0, and then plus 3. And so again, when you're finding the y-intercept, it's always the same step every time. Put 0 in place of x, use PEMDAS, figure out what your answer is. So in this case, it's going to be 0 squared is 0, 0 times 1 is 0. Then I'm going to multiply 2 times 0 to get 0 again. And then just drop my plus 3 down. 0 plus 0 plus 3 is just 3. And so, just like that, I found my y-intercept. So now I'm going to come over here, Go to my graph, find 0, 3, and that's going to be another point on the parabola. Alright, so let me backtrack for a minute. So far I found my A. That will be the easiest part. Just look at your number. Make sure you do describe it for me. I found my vertex to be negative 1, 2. It is the green point on the graph. I found my AOS, my axis of symmetry, to be the equation x equals negative 1. Again, that's the dashed line. And I found my y-intercept to be the point 0, 3. All right, last thing we need to do. We're going to pay attention to our A again. We made ourselves notes. It opens up and it's the same steepness. So I know the parabola is going to do this. I also know in order for me to find the symmetric point that I can actually just find it by counting. It's going to be a point. But the thing about the symmetric point is it's always the same distance from the SP symmetric point to the axis as it is to the y-intercept. So I always go back, just reminding you from before the semester ended, that you're going to count the distance from the y-intercept to the axis. In this case, it's just 1. You're going to go 1 more unit to the left in this problem. You're going to put your point, and then you're going to connect those 3 points to get your parabola. And so that's how you graph a quadratic function in standard form. There are 5 pieces you give me. I usually do start with the A first because it is the easiest to answer. And then with this type of problem, go straight to your AOS so you can figure out where the middle is. Then use your answer here for your vertex, for your X for your vertex. Plug it back in here to figure out what your Y value is. And then as soon as you find each piece, go to your graph and plot it. So to finish this up, I know my blue point on the screen right now is my SP or symmetric point. The location for that is negative 2, positive 3. And so that's what I record here. All right, so all the highlighted parts are the parts I'll be looking for from you in your assignment, in your practice set, plus the picture. Okay, we are going to try one more example together, just to make sure that you see it again, understand what I'm expecting you to do. Okay, we'll start with the A. The first graphing criteria. Well, let me back up. First thing you do is look at your problem. We have a quadratic term, we have the linear term, we have the constant term. If any of your questions are missing a piece, like it shouldn't be missing quadratic, but if it's missing this or missing this piece, go ahead and put like 0x in there or 0. So keep that in mind. If your problem is missing a term, you are allowed to put 0 in its place. The A in this problem is the coefficient of the x squared term. So in this problem, it's negative 1/2. To the side, you are then going to describe for me the 2 things that it does. First off, because it's negative, it's going to open down. Secondly, you're ignoring the sign, you're just looking at the number, 1/2. 1/2 is definitely less than 1, so it's going to make the parabola less steep, or you can say wider, either way. Vertex. Well, I can't find the vertex just by looking at this because it's not in vertex form. So I'm going to go straight down here to my axis of symmetry. I'm going to have to use my formula. And then we're going to work it out to the side. So x equals negative. My b this time is -3, so it's -3 on top, divided by 2 times the a value, and my a in this problem is -1/2. All right, so continuing down, I have -3, so there's a +3 on top. And on the bottom, I get 2 times -1/2, which is -1. And so that's showing me that my axis of symmetry is 3 divided by -1, or just -3. So that is what I should get for my AOS. Okay, I'm going to come over here, same thing I did last time. We're going to go to the graph. We're going to find x equals -3. Find your x-axis, go to -3, and draw a dashed line through it. Again, that is the middle of your parabola. Now I need to backtrack and go back up here and find the actual location, the vertex. It's somewhere on this line. Because I already know the x value, I'm going to go ahead and just fill in -3 for the x coordinate, and then leave the y coordinate blank until I find it. Again, to find it, you go back up here where you see x, you're going to put -3 in this time in its place. So your problem is going to be y equals -1/2 times -3 squared minus 3 times -3, and then plus 3. And you're going to do PEMDAS. So let's see what I can fill in here. -3 squared is going to give me a +9. So right now I have -1/2 times +9. And then -3 times -3 is a +9 as well. And then plus 3. And you're going to show the rest of your work here. -1/2 times 9 is -4.5, plus 9 is 4.5, plus 3 is 7.5. So when you go back to fill it in over here, your y value is 7.5. Immediately when you find it, go back over to your graph and locate that. So -3 up 7.5. And so that right there is going to be your vertex. Okay, so let me grab my highlighter here. Right now I know my A, I know my vertex, I know my axis of symmetry. Okay, so got my vertex, axis of symmetry. Looking back at my A, it's negative, so I know it opens down. I also know that it's going to be less steep, but I don't know exactly what that means. So I need to figure out where the y-intercept is, so that way I have a better graph. For the y-intercept, do the same thing we did on the last one. You're going to substitute 0 in place of the x. So your problem is y equals -1/2 times 0 squared minus 3 times 0, and then plus 3. You're going to work that out. Y equals 0 squared is 0. 0 times anything is 0. Then this piece, -3 times 0 is 0. And then you're going to drop your plus 3 down. And so right now we're looking at y equals 3. So your y-intercept, the place where this graph crosses the y-axis, is the location 0, 3. We're just making sure we understand where that came from. As soon as you get it, you come over to the graph and you locate it and go ahead and put your point. And that's a big help because now I know how wide to make that problem. So here's my vertex in blue. My red point is my y-intercept. Notice that the red point is 1, 2, 3 units away from the axis. So I then need to go 3 units to the left because this one's going to open down, remember. So 1, 2, 3, find your symmetric point. Kind of block this off. So all that work was y-intercept. And now for your SP, you really don't need to show any work. You just need to count and write down your answer. And so that's the green point here. So if this is the origin, left 1, 2, 3, 4, 5, 6, and up 3. So negative 6, 3. And all we got to do now is finish it by connecting these points. And so it does open downward. Try your best to make it look like a U instead of a B. And that will be your picture for negative 1/2 x squared minus 3x plus 3. Okay. All right, again, we were graphing quadratics in standard form. So 5 pieces of criteria, show all the necessary work that you need to, which is exactly what I modeled to you today, and then give me a really good graph on graph paper.